Okay. So, welcome, friends. We've got a crazy prezzo, as I alluded to previously. This is going to be, we're going to see how it goes, because to be real, they talk about live demos are, very bad luck. This is like live demo like times 10. So get ready. We'll see. Okay, so what do we have? We have it's 3:53. What am I gonna be telling y'all about? I'm going to be going through the Superchain Interop DevNet tutorial and starter kit. And then we are going to go into a experimental Interop repo and thing that I've been working on, which I was calling the futuristic Superchain starter, which is probably broken. And as you'll notice, my latest commits were as of 19 hours, 38 minutes ago. So trust me when I say this is a live demo. This is a extremely alive demo. So okay, real quick, what is native interop? What is this thing? Well, I hate to break it to y'all, but we solved Ethereum interoperability. We did it. We can go home. No, but actually though, for real, it is actually very exciting. This is the real deal when it comes to interop. It is chain A can read information from chain B, high security and with low latency. And by low latency, I mean a couple seconds. And realistically, if we fix the builders, it could be as low as same block. That whole silly meme that's probably not that useful of synchronous composability, it is on DevNet. It is not fully there on mainnet, but we are so close. So, what does this mean? It means that you are in on the ground floor. And if you don't believe me that there's a DevNet, I promise there's a DevNet because there's a block explorer. Things are not real, blockchains are not real unless there are block explorers, and we have explored. Now, we actually have multiple block explorers, but I'll get into that soon. And we're gonna see what it's like to build an example app. This right here is the first live tutorial about how to build an example app on the Superchain DevNet. So now, if you want to follow along, which I highly recommend, go to gist.github.com/opsuperchain, click on this gist. OP Superchain, it's not me, it's someone else. Someone else's GitHub. Now, what are we gonna do? So, thankfully, I have already downloaded and, I did a git clone, but I really didn't touch it. I promise I did not touch this thing. And by the way, let's look at it. Let's look at what we have here. So if I go to let me actually follow along with the tutorial like I'm supposed to. Boop, boop, boop. We're gonna go to, here we go. Superchain Starter Kit gives you a few nice things. All you need to do is you clone it, go into your repo, pm-pmi, and then pm-pm dev. Super simple. So why don't we do it? So, by the way, I whipped out my old Vim and tmux configs for you. Not because I use Vim and tmux anymore, but because I wanted you to know I know the key bindings, but I still choose not to use them. Okay, where are we at? So, this is actually really shout out to the DevX team. They did a really good job with this. This is pretty cool. So what did we actually do? I started up the development environment. Spins up SuperSim. What does SuperSim do? It deploys 2 chains, kind of like, testnet chains, right? And it has auto relay enabled, meaning that if you send a message, initiate a message on chain A, it will automatically relay on chain B. Now, notably, this relaying is asynchronous. So we are moving into the world of Solidity programming with asynchrony, which is extremely exciting and also very scary. But for the purposes of this demo, it is extremely exciting. And what actually happened in the background? Well, one, it ran this deploy contracts CLI. This is like super CLI. It deployed 2 contracts. It deployed a counter. You need a counter in your starter kits. Deployed a counter on chain A and a counter on chain B. Now, something that you will note about these counters is that they are deployed via create2. We know that it is very hard to deploy these contracts in a multi-chain context. We need to make sure that all of the addresses are going to be the same on all of these chains, which means that we've had to build out tooling to make it easy to deploy your contracts on various chains. So here we go. We've got the logs from the SuperSim A and SuperSim B, and chain A and chain B. And we've got this beautiful little front end, which I will then pop open. Oh yes, I forgot. I need to click C, and then boom, we're here. Okay. So what does this what does this do? Pretty simple. We have a counter, and your normal counter, all you would do is you'd click the incrementer, and it would increment the value, right? That's like your normal counter thing. Next, we have the L2 to L2 cross-domain messenger counter, AKA the cross-chain counter, where what I'm doing is I am actually sending a transaction on chain A, and that is initiating and incrementing the counter on chain B. So I can, send it again, and you'll note that it's a little bit slower than the single chain. Now, I haven't proven to you that I'm actually doing cross-chain interactions here, but you can kind of get an intuition because of the latency. There are really 2 transactions going on when I'm doing the cross-chain version of this counter. But now, to actually prove to you that I am doing this remotely. Oh, I actually had some logs which would have proven it to you. But what I'm going to do instead, because I feel very cool, is I'm going to move to the DevNet config. And then what I'm going to do is I'm just going to serve. Actually, I'm going to look up the NPM thing. There we go. OK, dev front end. Makes sense. Checks out. And what I'm going to do is run the front end. And so instead of connecting to my local environment, let me pop it open. This is the diff. This is the delta. I'm just changing the, from using the SuperSim L2 to using the Interop alpha. Great. So now let me pop it open. Boom. We've got some different chain IDs. It's promising, thank God. The other thing that you'll notice here that's actually kind of cool, it says that the counter is already incremented to 3. Why is this? Well, it turns out that I've already deployed this contract, and because I've already deployed it, but the address is deterministic based on the bytecode. If you don't understand the words that I'm saying, I really do apologize, but create2, it's really cool. I'm going to call this function. This is a cross-chain message. Now, I happen to open this Explorer, open to this particular address. Why is that? Because I think that it is the correct address. It is the correct address. We have found this transaction 12 seconds ago, 19 seconds ago. If you were timing it, it would line up perfectly. And we've actually, instead of incrementing on my local machine, I can send a message, and I have incremented yet again on the remote DevNet. So, y'all, if you literally, here's what I want you to do. Okay, you get a golden star if you open up this. Where did I put this gist? If you open up this gist and you follow all the steps, and then you increment the counter before I'm done talking. If someone does that, that's very impressive. I will be impressed. I won't know who you are unless you tell me, or if you claim credit for someone else's work. Okay, so we have officially done the thing. We are literally, and by the way, I don't know if y'all really appreciate. If y'all really appreciate this, the fact that we have this DevNet that allows you to, in seconds, move information from one chain to another. I remember I didn't actually tell you why Interop is so insanely crazy, but like, think about all of the horrific fragmentation in Ethereum right now. You try to deposit into a chain, or sorry, you try to just put your token on chain. Let's not talk about deposit. What does that mean? You try to get an on-chain asset, you're confronted with a disgusting dropdown, truly abysmal, of a million different networks. This needs to go away. The only way for this to go away is if where you deposited your asset does not actually matter, because you can move your asset from chain A to chain B to chain C within seconds. And as it turns out, that's exactly what we did in this demo. We moved from chain A to chain B. We did not go to chain C. Okay, so now that we are done with the kind of like the basics, which I think, first off, extremely cool. Part of me wants y'all to applaud right now. It really is amazing. I mean, like, look, it's so anticlimactic, but that's what you get for building infrastructure. Okay, truly, blood, sweat, and tears. Okay, so next up, what do we got? We've got a futuristic, universe. Let me actually pull back before I even get into my like live demo bit. So I just want to mention that this is really the beginning of a new paradigm. We are entering an age which we knew we would enter in Solidity blockchain land, which is we need to build applications and programs and smart contracts asynchronously from the get-go. And so what that means is we need to support things like promises in Solidity. We need to be able to do, perform callbacks. We need to do async await. We need, as I said, better cross-chain deployment tools. I went through the ones that we built, but this is just the tip of the iceberg, and there's huge amounts of improvements. And literally something as simple as upgradable cross-chain proxies. How do you handle upgradability and keeping all of your smart contracts in sync if they're deployed to many chains? There is a literal huge number of things to build. And by the way, yes, indeed, we have 40,000 somethings of bounties, which you should contribute to in this hackathon. So definitely for real, I think it's very, very cool. Okay, now I will show this kind of crazy version of the front end and general. Yeah, I'll show you a kind of crazy version of the counter. Let me increase my zoom. Okay, so by the way, I'm going to be giving this talk tomorrow at a Superchain event where I'm going to actually try to complete the entire application, because looking at the time, I think I'm really, really running low. But I will still be able to show you, like, for example, something that you should be able to do very simply in the near future, right? This guy is the cross-chain counter. It is async enabled, meaning that it can make these cross-chain calls. Again, this is a protocol level feature. This is the same level of security as, a cross-contract call, right? This is baked into the protocol. It's not like a extra wrapper with a relayer. So I'm going to call this increment on chain function. I'll give it my chain ID. And what I can do in this particular library, this is not the best syntax, and this is like tons of room for improvement here. But what I can do is I can make this cross-chain call, use this, get this proxy, make this cross-chain call, and call cross-chain get implement. Cross-chain increment, and boom, increment on the remote chain. Then I can add this actually returns a promise, just as it does in Solidity, and I can register a callback with a .then, just as I would in, I said just as I would in Solidity, I meant just as I would in JavaScript. And then I just emit an event with this, right? This whole thing is incredibly, this is a whole new side of Solidity programming, which will contain an enormous amount of bugs, an enormous amount of gotchas, but still very, very cool. And what I might do is I can npm test. Let's run the tests. And what I end up, how do the actual tests look? By the way, I recently added some tests. I know the counter tests work. It's unclear if the other tests work. But I just wanted to show, like, even cross-chain front-end code will change with this stuff. So first off, we're not going to be operating in a context where it makes sense to have one RPC provider anymore. Like, or maybe it still makes sense to have one RPC provider, but one RPC endpoint. Maybe there's a meta endpoint, but the point is you'll need one endpoint per chain. No question. The other thing is, well, this is just a wallet with private key. That's the testnet private key, don't worry. But unless it isn't, and there's actually a massive bounty sitting there for someone, lucky you. Okay, but point being, super contracts. This is another thing that is like kind of a weird abstraction, but it makes a lot of sense when you start building your smart contracts in this cross-chain context, right? Instead of deploying, having a single contract instance in your front end per deployment, you really want to be able to operate on all of your deployments at once. You want to be able to make calls to the same functions. The function is number, for example. But you want to be able to specify the chain ID. Which chain ID, well, you know, your contract may have hundreds of instances across the superchain. You're going to need to make these calls directly. And, you know, similarly, sending transactions. So we've got 15 seconds. All I have to say is this, if I had, you know what, I will do it. This is a green field. Literal, one of the greenest. In fact, I would argue probably the greenest in crypto. And so if I were you, I'm not, and I'm also very biased, but I really would consider building on top of Interop, building some of these primitives, because you don't have to be smart to push the state of the industry forward right now. You can be you can have very mid-curve ideas, and it will be brand new because no one has built cross-chain smart contracts before, ever. So this is the first opportunity. It's literally the first DevNet that is public for Interop, for Ethereum. Let's solve fragmentation and save the world. Thank you.